I'm going to solve problem number 12 from homework 3. This is from chapter 5 in this video, and this is one that is very interesting and has to do with Bayes' theorem. So let's look at that problem in Connect. So it reads, a biometric security device using fingerprints erroneously refuses to admit 1 in 1,000 authorized persons from a facility containing classified information. The device will erroneously admit 1 in 1,000,000 unauthorized persons. Assuming that 95% of those who seek access are authorized, if the alarm goes off and a person is refused admission, what is the probability that the person was really authorized? So that's the question. This is something that you might see anytime you've got a like a security station where either a computer, or it doesn't even have to be a computer, it could be a security guard looking for people that are trying to break in illegally. The same sort of thing happens when you're go to the airport and they're screening baggage and that sort of thing. They're looking for people that are trying to bring things on the airplane that could be dangerous. So let's go back over here to our PowerPoint and write down the things that we need to. First of all, we're going to define two events. AU means that somebody is authorized, and AD means that somebody is admitted. So the question we're being asked here is, if the alarm goes off and a person is refused admission, okay, so given that that has happened, so we're going to write that as not admitted. That's what we're conditioning on. What is the probability the person was really authorized? So what's the probability that they're really authorized? So we want the probability that they're authorized given that they were not admitted. That should be a straight line, and I keep trying it not so straight. Okay, so we're going to use Bayes' theorem to figure this out. This is going to be the probability that somebody is not admitted given that they're authorized times the prior probability that they're authorized, all of that divided by the probability of not being admitted. So the way we have this set up is we want to know what the probability is of being authorized given no admission, and we can start with the probability of being authorized as the prior probability. So we're told in the question that 95% of those who try to get in are going to be authorized. So probability of authorized is going to be 0.95, and now we're going to update that. We're going to say given that they're not admitted, what's the probability they're authorized? So what other information do we have here, or what do we need? Well, let's first of all write out the probability of not being admitted. That's going to be the probability. There's two ways this can happen. You can be not admitted given that you're authorized, multiply that by the probability of being authorized, and you can be not admitted given that you're not authorized, and multiply that by the probability of not authorized. Okay, so what of these do we know? Probability of no admission given that you're authorized. Is that something that we know? Come back over here and it says the device erroneously refuses admission 1 in 1,000 times to authorized people. So given that you're authorized, probability of not being admitted is 1 divided by 1,000. Okay, what other information are we given here? The device will erroneously admit 1 in 1,000,000 unauthorized people. So given that you're not authorized, the probability of being admitted is 1 over 1,000,000. So we have this one, that's 1 in 1,000. we have this, that's 0.95. We have this, that's 0.05 because of the law of complements. Probability of not being authorized is 0.05. And so now we just need the probability of not being admitted when you're not authorized. So how do we get that? We're going to use the law of complements again and say that this is going to give us the probability of not being admitted given not authorized, and that's 1 minus 1 over a million, so that's 99999 divided by a million. Okay, so we've got everything that we need. Notice that this numerator here is actually part of the denominator. Okay, so let's just plug these numbers in, and we'll get 1 over 1,000 times 0.95 divided by 1 over 1,000 times 0.95 plus 99999 over 1 million times 0.05. And that's going to be equal to 0.00095 over 0.05095, and that's equal to 0.01864573. So what this is saying is, given that somebody was not admitted, the probability that they were actually authorized is about 2%, 1.8%. And that's what the question is asking us. If we go back over here, plug that number in, 0.01864573, and we check our work, we should get it right, and sure enough we do. So that's how you do that question, and very interesting what's going on here. You would think if you're not authorized, if you're not admitted, that means you're not authorized, and that's not the case, because there are mistakes that are made when this machine, whatever it's doing, is trying to identify authorized people or not authorized people. So unless you have 100% probability of not being admitted when you're not authorized and 100% probability of being admitted when you are authorized, then things are not as they always seem. And this Bayes theorem protocol is something that you need to be able to know how to use in order to assess the probability correctly. So that's it for this video. We'll see you in the next one. Send me an email if you have questions.